So we're going to look at contingency tables now, and basically we've got the example which is out of the book. Some cinema manager wanted to know if there's a relationship between horror films and action films to see if they can put on action trailers when horror films are on, or horror trailers when action films are on, so on and so forth. So what we have here is a contingency table. Now obviously it just looks like a normal two-way table, but with a few bits missing, and those are going to be our little totals. So I'm just going to add in our marginal totals, RG in our totals, and I'm going to do them for both sides. Oh, I've spelt it wrong. See what, if I rub it out, no one will know. Let's shrink my eraser size down. Look at this, it's like it was never there. So, marginal totals. Now, obviously, we've got the marginal totals for our action films. So these are our action films, and this is for our horror films. And you think, well, why are they on a different side? Because enjoyed horror, well, 51 plus 15 enjoyed horror. So this is the total for the horror side. So that means altogether 66 enjoyed horror films. Then we have 84 didn't enjoy horror films. We had 92 enjoyed action movies, and we had 58 didn't enjoy action movies. So altogether these two should add to be 150. And that's the total number of people asked altogether. 1, 2, 3, 4 added together makes 150. So what we now have is we have our table which says, oh look, this is the data that we've then got. And what we can then do is produce another table, and that table will be what we expect people to do. So give me a second. So there we go. So this is now going to be our table for what we expect. Now remember, expectation is quite an easy thing to do. What I'm looking at here in the original question was to say, is there any relationship between those who enjoyed horror and enjoyed action, so that can I put action trailers on horror films and horror trailers on action films? Now, to do that, the first thing I'm going to do is assume that there might not be a relationship, that these are totally independent of each other. And that way I can show that there is a relationship or not. So what I'm going to do is say, well, if they are totally independent, then what is the probability of enjoying horror and enjoyed an action? Well, little tree diagram, I enjoyed horror, I enjoyed action, and so I should really just times them together. So that is 66 out of 150 enjoyed action, enjoyed horror, times by 92 out of 150 who enjoyed action. And remember, this is my expected value. So, well, I've got 150 people. So out of 150 people, I expect that probability. So I'm then going to do 150 times all of that. And then again, I'm going to follow through the similar principle. So 84 out of 150 didn't enjoy horror. 92 out of 150 did enjoy action. And so that's my probability of those who didn't enjoy horror, but did enjoy action. And I've got 150 people, so the expected value is 150 times all that. Now, if I fill out the rest of it, then I'm going to start putting some numbers in. Now, notice once I've filled all of this in, you could actually, if you wanted to, make it a bit simpler, because the 150 is going to cancel in each of these. So what I could do is do 92 times by 84, divide by 150. 58 times 84 divide by 150. That will still get me the same value. I prefer to do it this way just because it makes more sense, and remember, in an exam, if you get a bit lost, this way you can actually understand. So I'm going to fill all these out with actual numbers. So there's my table filled out nicely, and I've got all my expected values. You'll notice I've left one of them in light blue, and I've done that on purpose because actually what we also need to look at is the degrees of freedom that we have. Now, the degrees of freedom basically are, how to describe it, you have the freedom, for example, to go out and do stuff in an evening if you want, but obviously there's a constraint. So let's say you're in a classroom and one of you is allowed to leave the classroom at a time. Well, if one person's left, you don't have the freedom to go out. If there's no one left, then you have the freedom to go out for one of you. Here, if, for example, I've got, let's call this 40, just to make my numbers nice and easy. If I've got 40 people in this category, well, because the totals are out of 92, because these marginal totals won't change, because remember, I expect out of 150, 40.48 to enjoy horror and enjoy action out of all the numbers that I've got. So if I know this number in blue, actually, this one here, it's fixed. There's nothing I can do about it. There's no other option it can be. It can't be like 60 or anything like that, because then they don't add to be 92. And this 25.52, that's fixed as well. It doesn't matter what I do, because this number in blue is there, that has to stay the same, because they must total 66. And so as a consequence, since that's fixed and that's fixed, this one is also going to be fixed. And so I only actually have here 1 degree of freedom. As soon as I put one number in a cell, the rest are fixed in stone. So if I make this number 1, that's 91, that's 65, so on and so forth. They're all stationary. Now obviously I can't have 65 there because I've only got 58 people, but you get the idea. So the next thing I'm going to do is put a little summary table on there, which Blue Peter style I've just done. And this just basically has the observed frequencies and the expected frequencies all together as one. So what we're now going to do is have a look at this, and as you can see, 51 versus 48, 40.48, so on and so forth. There's not really much I can tell. So what we're going to do is actually then officially do a chi-squared test on it. Now a chi-squared test will basically give me a number which I'll then be able to have a look at and compare to see whether or not, as my first point was, whether or not there is, if you enjoy horror, you enjoy action. So really we've done a bit of hypothesis testing here by saying, well actually, H0, enjoyed horror, enjoyed action, there's totally independent of each other. H1, enjoyed horror, enjoyed action, there is some dependence, i.e. they're not independent. So to do the chi-squared test, what I'm going to need is I'm going to need my value of x squared, which is going to be my observed frequencies, so the values I observed, minus the expected frequencies, so the values I expect, squared over the values I expect. Now obviously I should really put observed frequencies and expected frequencies, but I'm going to run out of space otherwise. Now I've got 4 numbers there, so I'm going to sum total them up at the end to give me a little value. So let's actually do this time at a time. So I get 51 minus 40.48 in brackets squared over 40.48 plus, where's the next one? 41, and I'll fill in the rest. So there we've got the values filled out. Now remember, we were doing a 2x2 grid, and so it's just a little shortcut. Obviously I like it to do it all at once, but a little shortcut. I've written out this line as well on purpose, because notice all the values are 10.52 on the numerator. That isn't coincidence, will always happen with a 2x2, so because I've only got 4 cells in a 2x2, that will always be the case. With a 2x3 or a 3x4, well, bad luck, you're going to have to do it all by hand. Now we've got this value of 12.626, and so what we're now going to do is have a look at that value in our chi-squareds. Now obviously when we're looking at our value, we've already had a look quickly, and I've mentioned it rather than writing it down, at our hypothesis. H0, they were independent. H1, they were not independent. Not independent. And so what we're looking to do is test this. Now remember, back to your testing, there was always a significance level. Here, the significance level, I'm going to use 1%. You could use 5%, and actually I'll show you the difference with a significance level each time. Now, we talked as well about another important bit of information, which was this light blue bit, and that was the degrees of freedom. So here, the degrees of freedom is 1. So that I am also going to need to know. So I need to know my degrees of freedom is going to come out to be 1. Now, with all of that information, I should be able to go. So the 12.626 is the important bit, but if we look at our formula book, which is here, so I'm looking at 1%, so we'll look at the 1% there. Notice there's a 5%, there's a 10%, so on and so forth. So at the 1% level, with, where were we? 1 degree of freedom, the value that I can find here comes out to be 6.635. So that is the value I'm looking at. Now what we have is we have a value of 12.6-ish. And so, well, if I look at 12.6, and actually I'll just nick this diagram here. So there's the diagram stolen. So what we found is that this value was about 6.6. And our formula book, let's get it back to where it was, 6.635. So 6.635. We've got a value which is up here somewhere at 12.626, if I remember correctly. And so you can see this is going to be our critical region. We're clearly outside of the critical region. So it does tell us that we can reject H0 and accept H1, implying that there is some relationship between horror films and action films. And so effectively that's what we've been looking at doing. Now, just one last point to mention before you go. I've mentioned degrees of freedom, and I've put down that there's 1 degree of freedom here. If you were to get a table which was a slightly bit bigger, so if we were to get a table, let's say, what should we go for? We'll go for 3 by 4. Then working at your degrees of freedom is actually quite easy. Because if I say knew the total, so that's got to be 100, this has got to be 10, this has got to be 50, so on and so forth, then the number of degrees of freedom I need, well, I'm allowed to choose that value, I'm allowed to choose that value, and I'm allowed to choose this value, but this value is going to be 100 minus those 3 values. So that is not a freedom, doesn't have any freedom in it. Because, let's say, we'll call this one 70, 60 and 30, or whatever the numbers are, 200 or something like that. Because that totals 70, well, I'm allowed this value, I'm allowed this one, but this one will be 70 minus whatever they are. So that's not free either. And following a similar principle along this way, that's free, but that won't be. That's free, but that won't be. Following the same principle here, that's not free. And, well, the sum total of them must all add up to be, I'm making these numbers up totally, 1,000, so I know that that one's not free because they've all got to add to be 1,000. So here, in a table with 12 possible numbers, I know that actually there are only 6 degrees of freedom. Now, an easy way of working out the degrees of freedom would be to say, if I had m rows and n columns, then the degrees of freedom will be m, take 1 away, times by n, take 1 away. So in this case here, I had 4 rows. Notice only 3 of them will be free. I had 3 columns, but again only 2 of them will be free. So 3 times 4 is 12, but take 1 off the 4, take 1 off the 3, 3 times 2 is 6. So if I had a 10 by 8 column and row, then it would be 9 by 7 would be free. So now have a look at example 3.